Okay, so I want to go over how to practice figuring out which type of intermolecular forces you have using this intermolecular forces worksheet. So what I see here, sometimes students will just pick some intermolecular forces without really considering the Lewis dot structure for these compounds. So I want to just go over some examples here. So if we look at H2S, it's really important that you draw out the Lewis dot structure. So we have two hydrogens with the sulfur, and then we have the two lone pairs there. And then if we look at this is going to be a bent structure, so it's asymmetrical. So that's going to be polar, and as a result, it will have dispersion forces and dipole-dipole. Okay, let's look at another one here. If we look into H2, so again, we need to think about how many valence electrons we have. So we have 10 from the nitrogen, and we have 2 from the hydrogen, so we have 12 valence electrons. And if we draw the structure out, we would have the 2 nitrogens in the center with the hydrogen on either side. And then we know we have 12 valence electrons. So I know nitrogen likes to have 3 bonds, so I'm going to assume it's going to start out with a double bond between the 2 nitrogens. Let's see, 2, 4, 6, 8, 10, 12. So it has 12 valence electrons. Now, this is going to be asymmetrical because of the lone pairs. And then we know we have a dipole. We have actually LDF, London dispersion forces. It's asymmetrical, so it's going to also be dipole-dipole because it's polar. And then we notice we have hydrogen attached to nitrogen with lone pairs of nitrogen. Nitrogen is one of our atoms which we could have the possibility of hydrogen bonding with. We have the conditions necessary for hydrogen bonding, so we also have H bonding. Okay, so when you're doing these, you really need to look at your Lewis dot structure. If it's nonpolar, it's going to only be London dispersion forces. If it's polar, you're going to have dipole-dipole and London dispersion forces. And if you have hydrogen attached to either nitrogen, oxygen, or fluorine, and there's lone pairs on that particular atom, then you also have hydrogen bonding. The strongest force will be hydrogen bonding, the weakest will be LDF. So, and on this sheet, you will see that you want to determine the main intermolecular force, and that means the strongest one. But please list all the forces that you know will be present, but identify the strongest of the ones that are present. Okay, so good luck on this.